7.2 Properties of Parallelograms. I want you to take a look at your student journal. And on your student journal, page 202, you'll see these properties. In fact, I'll put page 202 up there. That's kind of in the book format, but that's what page 202 looks like. You have two properties right there. I want you to go ahead, or two theorems I want you to read through, make any quick notations you need, and then once you're done with that, look at 203 and do the same thing on those two theorems. Okay, make any notes you need. 4 theorems to review, 202 and 203. Okay, hey, the two theorems, 7.3 and 7.4, opposite sides theorem states that opposite sides of a parallelogram are congruent. Okay, and opposite angles of parallelogram are congruent. 7.5, consecutive angles theorem, or another way of saying same side interior angles. Remember, if you have parallel lines, then the angles formed by those parallel lines and the transversal that cuts through those interior angles add up to 180 degrees. That's what the consecutive angles theorem says. And then the last one, parallel diagonals theorem, says that diagonals bisect each other in parallelograms. All right? Using that, and I'll actually give you a page to help summarize this stuff here in a while, but using that information, I want you to look at page 204 and complete the extra practice. Okay, you can work together on that. Do your best there. All right, let's go ahead and do 1, 2, 3. Can I get a volunteer to do 1 up here? Yeah, Drew. All right, volunteer to do 2. Isaac, you got 2? Cool. Volunteer to do 3. All right, Alex. Very good. Show your work. All right, if you haven't done so already, compare with your neighbors, questions 1 through 3 there. If you have 4 through 10 or 11, then go ahead and compare those as well. Yep.
So why did you do so many? Why did you do so many?
I used to do 4 through 11.
How do you
Stop. Follow lines.
Carson?
Yeah,
Just comparing answers to you and them. Seeing if you are correct. Compare. None of you are always correct.
You're being an Isaac.
You wish. And you can do anything if you want. If you just be that way.
All right, check them out. Okay, so 1 through 3, we've got our work here. So number 1 looks like we have a solution of y equals 40, x equals 10. Okay, remember you're setting your sides equal to each other, so this side equals that one. And went through and did the work there. Is this true?
Yeah.
Nice work, man. Okay, once you find x, you can plug that in for 4x, and then that's 40, so y equals 40 because opposite sides are equal. Number 2, we have 415. All right, opposite angles are equal, so we set them equal and solve. Okay, so in this case, we get the angle, and then once we know x, we can plug that in right here. So x it looks like is 21.5. Okay, so we'll circle that there. Plug the 21.5 in here, and then that helps you to find the y value. Very good. Who did number 2? Nice work, man. No, you did? All right. Did you do number 3? No?
Alex did number 3.
All right. Who did number 2 here? Is that Isaac? Okay. Who did number 3?
Alex.
All right, Alex did number 3. Okay. And so we get 8 and 6. Those are equal. Okay, those are equal. Diagonals bisect. So you set them equal to each other and solve. Very good. There's your work. Okay, number 4, Maddie, what'd you get? 24. All right. How'd you get that?
The length of at the end is 24, and they're like, yeah.
Good. Parallelogram opposite sides theorem, right? So that we want to kind of state our theorem there. So since that's 24, that has to be 24. I think that's where Maddie was going with that. Okay. OQ. Danica, what'd you get for OQ? 14. All right. And how come?
Because they're equal.
What are equal?
NQ and Q are equal.
How come? You're right about all this. Okay. There's a special theorem you want to do. Okay. Diagonals. Yeah, it's parallelogram diagonals theorem, right? Reference those theorem on the previous page. So Danica, you're right for sure. Just want to reference the theorems. Okay. All right, Sam, what'd you get for number 6? Thank you. 26. How come? Did you get NO? Okay, so we're using the parallelogram opposite sides theorem. Okay. PQ. Yeah, Brennan. Is it 20.7? I think it is 20.7. Yeah, so parallelogram diagonal theorem. Yep, good. Our angle PMN. Amanda, what'd you get? So that one. What's that? You didn't get that one yet? Anyone want to help out? Okay, Maddie? Yep, number 8. What? Parallelogram. Can't use opposite sides because it's an angle. You could use consecutive angles theorem. So this angle PMN. So this whole thing right here and this whole thing right here, those two, since these sides are parallel, those two add up to 180. So 68 plus what is 180? I think it's 59. So 180 is equal to 68 plus measure of angle PMN. What'd you get here? Okay, so 112. Okay. Yeah, 112 for sure. Good. These two have to add up to 180. Okay. Nope. NOP. NOP. So these two have to add up to 180. Right? So what's this one have to be? Tell your neighbor what you got there. Okay, the other way you could look at it, what do we know about this angle and this angle? They're congruent. So what's it have to be? 112. So NOP, the whole thing has to be 112 as well. You can use opposite angles theorem for parallelogram. OPM, what do we get? So we got O, P, and M. What's this one have to be? 68. Same thing, right? Opposite angles theorem. Parallelogram, opposite angles. How about NMP? Or, excuse me, NMO. So this angle right there. So where the dot is. KJ? 59. How'd you get that? Can I help with that? If these lines are parallel, this yellow line right here, what do we call this? Anyone? Yeah. That's a transversal. And these angles right here, this angle and this one are alternate interior angles. Okay? And alternate interior angles are congruent. Yeah. So alternate interior angles. Okay? Now is that the way you use? There's other ways to get there. Okay? Okay. Very good. Any questions?